But this simple pattern may be upset by local condition. Example, Kotagaru, Kelantan receive most of its rainfall from northeast monsoon at the end of the year and Rangoon Burma from the southwest monsoon between June and September. As one goes further north and south of the equator, particularly in coastal districts open to the influence of the trade, the tendency is towards a monsoonal pattern with the heaviest rainfall coming in the summer months. Examples June, July, and August in the northern hemisphere and December, January, February in the southern hemisphere. So this we have to basically understand exactly how these pattern get modified. If you see this map, then you will find that in many places like this ITZ, this Rangoon, this here in these places, they receive rainfall through the southwest monsoon because when this trade wind, when they move, when the sun shift from here to the Tropic of Cancer in June, July, and August month in the northern hemisphere, then these trade winds actually also shift into this part in these areas, and that's why they take their turn towards their right in the northern hemisphere and they start moving in the form of this monsoonal wind. So that's why these areas receive rainfall in this through the southwest monsoon. Some areas also receive rainfall through the northeast monsoon, northeast trade wind. So these coastal areas especially they receive these. They have a different little bit of altered rainfall pattern within the equatorial wet and hot climate. So this is how exactly this precipitation gets itself modified. This tendency towards monsoonal pattern with the heaviest rainfall coming in the summer month. That's what we discussed. Now, due to great heat in the equatorial belt, morning are bright and sunny. There is much evaporation and convectional air current are set up, followed by heavy downpour of convectional rain in the afternoon from the towering cumulonimbus clouds. These things we have already talked about because in these areas, see, in the equatorial areas, we have already talked about these. This is ITCZ. So here, because of the heating of these areas, the air start rising. That lead to the formation of cumulonimbus cloud. Cumulonimbus clouds is a very large vertical extent, and that's why most of the rains are convection in nature. So this downpours of convectional rain in the afternoon. Thunder and lightning often accompanies the torrential shower. Definitely thunder and lightning is going to take place in cumulonimbus clouds because it has a very large vertical extent. Torrential shower and the amount of rainfall recorded in one single day afternoon may be as much as desert receive for entire year. So this cumulonimbus clouds always have a very torrential rain, means they can uh, they can make a huge amount of rainfall within a very short period of time. Like if you compare this cumulonimbus clouds with the clouds like uh, nimbus stratus clouds in the temperate cyclone, then these clouds in the temperate cyclone actually mm, can make rains which is not torrential nature, but they will be uh, like a drizzling. So these type of rainfall will keep on taking place for a long period of time, but in the form of only drizzling. On the contrary, these rainfall that takes place by these cumulonimbus clouds is a very torrential in nature, and within a very short period of time, huge amount of precipitation can take place. Uh, So, beside the convectional rainfall, mountains region also experience much orographic and relief rain. In addition, there are some intermittent shower from the cyclonic atmospheric disturbance caused by the convergence of air current in the doldrums. So these ITCZ also is known as doldrums. So these areas are also known as doldrums. So here some cyclone can also be formed, and in some places where mountains are situated, this rainfall can be orographic in also nature. Like for example, in these areas and these wherever the mountains are situated, then this rainfall can be also orographic. Relative humidity is constantly high, over 80%. Although the relative humidity is high in these areas, but if you will understand the relative humidity, then you will find that generally the relative humidity is depends upon the temperature. So that's why wherever the temperature is less, the relative humidity is likely to be high in these spaces. Absolute humidity is going to be high in those areas where the temperature is very high, because relative humidity generally, like for example, you some people may be having a misconception that the relative humidity is maximum during the summer, but that is not the case, because you may have found that in the winter season the relative humidity is maximum, because relative humidity is a you know is the it is measured in a percentage. So whenever the temperature drops, then mm, the the air get even more saturated, and consequently relative humidity becomes high. For example, we have already earlier also discussed, suppose this parcel of air, if at a 10 degree centigrade, it has a capacity to hold a 50 grams of humidity, and it actually has only 25 grams. It means its relative humidity is 50%, because its capacity is 50 grams, but it has only 25 grams at 10 degrees centigrade. So that's why its relative humidity is 50%. But suppose if the temperature drops to 5 degrees centigrade, then its capacity will become only 25 grams, and it will also have a 25 grams. So that's why its relative humidity will become 100%. So whenever the temperature decreases, the relative humidity generally increases. So that's why during the winter season or in the temperate areas, relative humidity is likely to be high. But absolute humidity is depends upon the temperature. So if the temperature is high and water bodies are present, then absolute humidity is definitely going to be very high. So relative humidity is high, very high. That's why it makes this. It makes one feel sticky and uncomfortable. Uncomfortable makes one uncomfortable. The monotonous climate, oppressive and enervating, taxes one's mental alertness and physical capability. Though along the coast, a refreshing sea breeze do bring some relief. We have already discussed what exactly the sea breeze is. Do bring some relief, because it actually moves from the ocean towards the land. That's why this actually is responsible for lowering down of the temperature of the coastal areas. As a result, most of the white settlers whose bodies are attuned to cooler and more varied condition takes to the polar highland wherever they can. So that's why they have actually the white settlers they actually built their you know dwellings in the cooler highland where the temperature is less. So this is what the climate of these areas is. Now we'll talk about equatorial vegetation. High temperature and abundant rainfall in the equatorial region support a luxuriant type of vegetation and the tropical rainforest. So we have already discussed that the temperature of these areas are very high and this area also receives huge amount of abundant amount of rainfall. So that's why the vegetation that is found in these areas are luxuriant type vegetation, which is also known as tropical rainforest. In the Amazon lowland, the forest is so dense and so complete in its vegetational extravagance that is why a special term selva is used. These forests is known as selvas in Amazon basin. Unlike the temperate region, the growing season here is all year around. Seedling, flowering, rooting, and decaying do not take place in a season pattern, so that some tree may be in flower while other only few yards away may be bearing fruit. There is neither drought nor cold to check growth in any part of the year. The characteristic feature of the equatorial vegetation may be summarized. So this area has a very high temperature and precipitation is also abundant. That's why luxurious type of vegetation is found. And because there is no season, we have already talked about that there is no season in these areas because sun remains over, almost vertical over these areas because it keep on moving from Cancer to tropical Capricorn. So that's why this area does not have any season. Throughout the year, you have a high temperature and heavy precipitation. That's why the trees are evergreen because they don't follow any kind of seasonal pattern because there is no season. That's why they don't have to follow the seasonal pattern. On the contrary, generally, if you will compare these forests with the forest that is found in the monsoonal type of climate, then because the seasons are present in these areas, that's why the generally the plant are not evergreen. They are deciduous in nature because they shed their leaf in order to preserve the water in during the dry season, and as soon as the rainfall takes place they start bearing the leaves because they have to preserve the water from getting evapotranspired. That's why they shed their leaf in order to preserve the water. But here in equatorial forest, because throughout the year you have a rainfall and temperature is very high, the nutrient cycle is also very fast. So that's why the plant does not follow any kind of seasonal cycle. That's why one plant may be having a flower, another plant may be in the same place, another plant may be bearing the fruits, and that's why they look like evergreen because the plant shed their leaf, uh, according to its own cycle, uh, not because of any seasonal cycle. So that's why you have evergreen forest. There is no actually limiting factor. So we will talk about all the characteristics of this vegetation. So first characteristic, a great variety of vegetation. Equatorial vegetation comprises a multiple of evergreen trees, over 150 feet um, long. Uh, they have a uh, uh, this equatorial vegetation comprises a multitude of evergreen forest, forest. So that yield tropical hardwood, mahogany, ebony, greenheart, cabinet wood, and dry dyewood. These are the some of the plants that you will find in these areas. There are smaller palm tree, climbing plant tree like liana or rattan, which may be hundreds of feet long, and epiphytic and parasitic plant that live on other plant. Under the tree grows a wide variety of fern, orchid, and lalang. So basically, these you have great variety because there is no limiting factor in these places. Like if you compare these areas with the other areas, like for example, desert. In the desert area, the water is a limiting factor. That's why only xerophytic type of plant can grow, which can withstand the water scarcity. Only so that's why the water is a limiting factor. So only xerophytic type of plant can grow. Take another example, like if the soil is saline, then only halophytic can grow. Halophytic can grow only in these places. But in these areas, there is no limiting factor. Precipitation is takes place all around the year, and the temperature is high. That's why every plant has any type of plant can grow in this area, and that is the reason you have a maximum biodiversity in these places. Some epiphytic or parasitic plant is there because in these areas the light is a light competition for light takes place. So the trees are very tall, and because they shut the light, you know, they shut this light coming to the ground. That's why all the plants, this liana, actually they are parasitic type plant. They go in search of light on the tree. So they keep on, climbing on the tree in search of light. So that's how these are epiphytic plants that are found in these areas. In these areas, you have a distinct layer of arrangement. Why this distinct layer is found? Because we have just talked about the fact that in these areas, light is a scarce commodity in these areas. So that's why all the plant try to reach to the light. So that's why you have a distinct type of layer in these places. So suppose one, these are the two trees, and the canopy is very dense in these places. So if some kind of light, there is a gap between these two trees, then another plant will grow and it will shed this light. And if it's still there, some light is coming onto the ground, then another plant will go and this will also shed this light. So ultimately, this canopy of this area is very dense, and light cannot penetrate onto the surface. So that's why you have a distinct layer of arrangement, distinct layer of tree. Like you have first layer, then you have a second layer, and you have a third layer, and ultimately these plant they will shut the light from reaching to the surface. That's why undergrowth is not found in this place. Under you don't find scrubs and bushes on the ground. So because light cannot penetrate onto the surface. This canopy is very dense. You cannot peep inside. If you go by helicopter, and if you try to take peep inside this vegetable in this inside the forest, then you cannot peep because this canopy is so dense that you cannot see the ground. So you have all plant struggle upward for sunlight, resulting in a peculiar layer arrangement. The tallest tree attain the height of uh, so only this tallest tree attain the height of over 150 feet. The slender trunks pierce skywards with the wide spread branches at the top. The smaller tree beneath form the next layer, and the ground is rooted with the forms and herbaceous plant which can tolerate shades. Because the tree cut out most of sunlight, tree cut out most of sunlight, undergrowth is not dense. This is what discussed just you have multiple species like unlike the temperate forest. where only few species occur in particular areas. The tree of the tropical rainforest are not found in a pure stand. What exactly is pure stand? Because if you go to the conifer areas, then you will find in these conifer areas, you will find that only you will have over large areas, you have only one type of tree. Only one type. If you have pine, you have pine, then you have everywhere you have pine only. Or if you have fur only over the large areas. But on the contrary, here in equator area, you don't have this type of pure strength in a very small areas. In a small areas, you will have multiple species. You have a different type of plant in found in these places. Only in one small area you will have a multiple species. That's why these the lumbering in these places is not as successful as in the temperate areas, because suppose in this case if you have to remove one plant, then you have to cut many plant unnecessarily which are of no use. But on the contrary, if you see in this in the temperate areas, you have only you have a pure stand. That's why you can cut from one side and all the trees are useful. So that's how exactly lumbering has been successful and more successful in the temperate areas than in the equatorial areas, because of the fact that we have multiple species in these areas. So it has been estimated that Malaysian jungle has as many as 200 species of tree may be found in 1 acre of the forest, and this has made commercial exploitation of tropical timber a most difficult task. Many of the tropical hardwood do not float readily on water, and that make the haulage as an expensive matter. It is therefore not surprising that many tropical countries are not timber importers, are net timber importers. Because the another reason why exactly lumbering has not been successful in those areas is because of the fact that these hardwood forests cannot float on the river. But if you see this, if you see this softwood forest, softwood, then generally what these lumberjacks do in the Canada, that they cut this tree, they make a log of this tree, and they will put this tree on the beds of the frozen river. So in the winter, so when the summer will set in, then this river, this water, this ice will get melted, and all the logs will start, flowing, flow, flowing down the stream, where exactly the generally most of the factories are located. So that's how these wooden logs, they can be easily transported over the frozen land compared to the these equatorial area. Here only rivers are the means of transporting these hardwood logs. So this is another problem in these areas. Forest clearing. Many part of the virgin tropical rainforest have been cleared either for the lumbering or for shifting cultivation. Where these clearings are abundant, less luxurious secondary forest called Velucar in Malaysia springs up. These are characterized by short tree and very dense undergrowth. So these forest clears in many part of the tropical rainforest has been cleared because of for the shift, either for shifting cultivation or for lumbering. So whenever these forests are cut, these plants are cut, original plants, trees, then generally the same type of plants cannot be restored, but they are succeeded by the somewhat less dense plant, which is known as secondary forest. Generally, they are known as belukar in Malaysia. So once you cut the tree, then you have a secondary type of forest. Not these forests will not be as dense as that of the uh, original forest. So that's why when the density between the tree will reduce, then definitely the undergrowth will start taking. This is undergrowth will come up. Why? Because when you have a more gap between these forests, then light will start penetrating, towards the ground, and definitely a lot of undergrowth will start taking place. So this is the reason why when the density of the forest decreases, then immediately the undergrowth start taking place. So Malaysia, these are the character short tree and very dense undergrowth. In coastal areas, bracket swamp mangrove forests thrive. Now we'll talk about life and development in the equatorial region.